Hi everyone, welcome. I'm having another talk at 4:15, and while I was watching the keynote from Suzanne, I realized would it be great? It would be great if I can also talk about serverless here. And there was an open slot, so I decided to share our experiences. So I work at a company called OpsGenie, and OpsGenie is actually acquired by Atlassian a month ago, so I now work for Atlassian. So we had some Lambda functions running in production, and I know that this is not something you see every day, so I hope that this will be a useful presentation and feedback for you guys. I'm curious, anyone using AWS Lambda on production, maybe? Cool. So just to give you some introduction, some sort of idea on what is serverless, in case you don't know. So for now, if you want to run your code on cloud, you have these options. You have bare metal, infrastructure as a service, EC2 in AWS case. You have containers as a service, platform as a service, Elastic Beanstalk, for example, and the serverless. So when you go down, you will have less control over things, and you will have less code to maintain, which has some advantages. So why should I go serverless? Is it just an abstraction? So there are two reasons, I believe. The first one is the principle, I believe, less is more. Basically, you have, with serverless architectures, you have less code to maintain. But this is the promise. It doesn't have to be always the case, but they are trying hard to make this happen. So you have less code to maintain, less operational burden, hopefully. You have less toil. This is a necessary term for the work tied to running a production service that tends to be manual and repetitive. And you have less, you have to care less about scaling, provisioning, operating system or language updates, resource utilization, and things like fault tolerance, even shipping logs. And the second reason is economics. Actually, probably this is the main reason under all of this cloud thing, obviously. So basically, if you are using AWS Lambda, you don't pay if you are not executing your code. If you are not triggering your code, it doesn't cost you anything. But if you trigger, and then you are going to pay for every 100 milliseconds you run your code. And it's relatively easy to get started, and often, although there are some challenges with the development tools and operational things, there are still a lot of operational things you have to care about. It's still a faster time to market, especially if you are not familiar with the operational stuff. So it is also all about economics, actually. And so I will talk a little bit about AWS Lambda and go into the serverless architectures part. So this is how AWS Lambda works. I took this from AWS feature page. It's pretty simple. So you package your code into a format that the cloud provider wants. It can be, for example, a zip file. For Java applications, it can be also a jar file. So you set up a trigger. It can be like 20 plus different AWS services, like HTTP API gateway service that provides HTTP endpoints, or it can be, for example, S3 service. So S3 is object storage service of AWS. So you put your objects, files, and it can trigger an event, and then you can grab that event within AWS Lambda and do things. It's pretty cool. That was actually the example within the keynote. And then you run your code, and you only pay for the time you spend. So the time you spend is limited. So it was 5 minutes before. It's now 50 minutes. But normally, for many cases, it should be about a couple of seconds. It shouldn't take that much. But you have limited time, and if you reach that limit, it's going to be terminated immediately, your code. And you only pay for just the time you use. So how it works internally, I also want to talk about this because it's important. So this is a simplified view that we created for one of our blogs. And let me use the mouse. So we have this kind of container manager thing, let's say. This is a term we come up with, but this is basically how this works. So there are containers, AWS Lambda users containers, but you don't see containers anywhere, except you might see container ID within the CloudWatch logs, but that is all you're going to see. And if you are making, this is for your first request, and then AWS Lambda creates a container. And when they do, there is a latency. And this is sometimes probably you hear it, but it is called cold start. So this first time you make a request, it doesn't, like, there are some other cases as well, but if a new container is created, then this is, there is a latency, and this is called cold start. And also, if there is available containers, and then AWS Lambda tries to reuse them, and there is no like certainty around how long AWS Lambda keeps containers alive, but it's about 5 or 10 minutes. But it can change. Like if you deploy a new code, it's going to be all containers are going to be killed, and you're going to experience some cold starts. So it's not just AWS Lambda, and if you are using a tool like AWS Lambda, you have other AWS services too. So for orchestration, this is actually relevant to microservices part. You have step functions. So I don't have experience, but as far as I know, like for small simple things, it's great. When things get complicated, it can be challenging. And also for deployment of your functions, you have SAM. SAM is AWS-backed tool. So I think like if I were to start any project, I would have used SAM. That would be my first choice. But you can also use Serverless or I don't know, Terraform, because you can easily switch providers. But deployment isn't going to be your only problem if you decide to switch provider. And you have AWS X-Ray for monitoring distributed tracing. And Tundra, if I have time left, I will talk about this. But looks like I don't have enough time. Basically, this is a tool that we created within OpsGenie to solve some monitoring challenges. This is now a separate company, has nothing to do with OpsGenie, but this is created within OpsGenie. And also there is a marketplace, so people put their functions there and you can reuse them. For example, like if you want to create a new Slack function, like slash command for Slack, and probably there's one over there and you can just go and try it immediately. So let's come to the OpsGenie part. So we use Java, actually. This is pretty interesting, and like for a conference like Voxxed Days, probably many of you use Java. So we are actually, I think, rare, because many of the folks who use Lambda uses with Node.js or Python. There are some advantages to those languages, like latency is a lot bigger with Java than the others, cold start latency. And we also use DynamoDB, SQS. These services are also marketed as serverless within the AWS, because these services don't require a lot of management. Basically easy to use. Our advantage is that with DynamoDB, for example, this is the NoSQL database of AWS. So you make a request, it's just an HTTP request. You don't have to keep connection pools. So it's going to be a lot easier if you use DynamoDB with AWS Lambda. And we use VPC, we use Serverless.js for deployment. So our journey started 2015, and we started writing small-scale applications. What I mean is, this small-scale applications basically was to our customers. So if one of our customers wants to integrate with OpsGenie, and then we often recommend them just use a Lambda function, write something with a Lambda function, because this is one of the best ways. And the reason for this is that we are going to talk about this later, but it's like we are an on-call and incident response solution, and this means that people send their alerts to us, and sometimes if there's an alert, we can trigger a webhook. I'm going to show you some examples. And in this case, people don't get a lot of alerts all the time, but when they do, they get a lot of them, right? And AWS Lambda is actually great for this, because often, like maybe they don't receive an alert even for a week, and then they're not going to be charged for anything. But if they receive a lot, it can scale immediately. So it's easy. So it's a perfect, I think, use case. And in 2016, we saw the first production usage within OpsGenie. So we basically used Lambda. I think this is how you should start. We basically started with things like, for example, DynamoDB autoscale. I'm going to show you some detailed examples. And in 2017, we decided to go a little bit bigger and try to implement a brand new, an important feature, just using AWS Lambda for everything. This feature isn't still getting a lot of loads compared to other parts of OpsGenie, but it's built with AWS Lambda. And while doing all the things with the service and incident management, we saw a lot of challenges with the monitoring, and we actually developed a new tool called Tundra, which is basically observable for AWS Lambda. So let's go to the serverless architectures. Again, I think this is still one of the perfect use cases. We still use it. So you can do custom integrations with other tools easily with AWS Lambda because customers don't need to manage servers. They shouldn't, like, it's just a basic simple script most of the time. And this is great for these use cases and easy to get started and deploy. Even if the customer like isn't really like experienced coder, it's easy to get started, and you're gonna just pay. Like if you are not triggering it, you're not gonna pay. So it's perfect use case. And one of the examples is, for example, you receive a message from Slack. You write something, like let's say OpsGenie create an alert or whatever. Like OpsGenie, there is a problem with the service, and then Slack can trigger a webhook, and this webhook can trigger an HTTP request, HTTP endpoint, and this HTTP endpoint is an API, AWS API gateway endpoint, and this API gateway endpoint triggers a Lambda function, so it's a triggering Lambda function, and within the Lambda function we have the Slack message, and we can just we can parse the message and decide which team we should be creating the alert for, or basically add some more details and create an alert using the OpsGenie API. So this is a simple example. So actually we have this OpsGenie's Slack application, but this is more flexible because you can also go ahead and maybe query some logging tools and get additional data and create the alert with more information. These are possible things. And this is actually one of the similar examples. So you can do alert enrichment. In this case, the alerts are coming to OpsGenie from AWS CloudWatch, New Relic, Datadog, whatever monitoring tool you use. And then there's an alert in OpsGenie. Then OpsGenie can trigger an HTTP endpoint through our webhook integration. And then again, the same setup. So we have the API gateway, and API gateway triggers the Lambda function. And within the Lambda function, we query the log entries API, for example, and then attach the logs onto the alert. So it's the alert enrichment use case. And the code is open source, so I'm going to share this presentation from our Twitter account. So this is actually, I found this is a great example because I believe that serverless architectures also can be used to glue things together. It's like just the perfect use case. And before AWS, I'm not sure if you are familiar with DynamoDB, but DynamoDB recently, just a year ago, I think it's been a year, but they recently added a new feature to DynamoDB called global tables. Global tables are tables running in multiple regions. So it's not just multiple availability zones within a region, it's just multiple regions. And because we have such high availability and reliability requirements at OpsGenie, because like when our customers are down, they are sending us their alerts, so we have to be up and running. So we decided to run DynamoDB within multiple regions, and there were no feature there was no feature like global tables at the time. So we needed to replicate all the data from our engine to another, and we just set up a Lambda function, 200 lines of code. It's just maybe 100 different tables, and they're just all easily copied to another region, and it can scale automatically. So it's just Lambda automatically creates a new shard, connects it to a Lambda function, and it can easily write it to another DynamoDB table. So it's pretty easy. And without this, we would have to use Kinesis client library and consume DynamoDB stream. And when DynamoDB gets a lot of requests, we probably would need to scale the machines. So it would have been a lot challenging than this setup. So this is one of the perfect use cases again. And another use case is DynamoDB autoscale. So even though DynamoDB has autoscale built in, so we needed something more complex because there are some restrictions, like you can only downgrade read or write capacity 4 times a day, things like that. So we wanted to build something more, let's say, smart. And because I'm running out of time, so I'm going to be skipping some of this. But basically, during migration, people can say, update this read capacity or write capacity from Slack, and then it goes to a Lambda function. Lambda function updates the item on DynamoDB table, and DynamoDB table stream triggers autoscale Lambda, and autoscale Lambda updates the actual DynamoDB table and updates the CloudWatch alarms. And also there's a periodic Lambda function. You can run Lambda function, for example, every minute. There's a trigger for that. So another Lambda function triggers CloudWatch. And this is, again, something operational, let's say. And this is the production usage that we see, like a relatively bigger one. So in this case, most of the function calls goes from an EC2 machine. So we have our applications running in EC2 machines, VMs. And we use, at first, we used AWS Lambda SDK to call the first function. But within the functions, we communicate through SNS. There are some different advantages and disadvantages for using Kinesis, SNS, SQS. Nowadays, you can use SQS as well because there's a trigger. And this is basically how we do. And later, we also used API gateway with service API. But I think API gateway has been very challenging and it's a bit more expensive than we would expect it, even though we don't care about the price that much. That was kind of challenging. And one of the also reasons that is challenging because, for example, API gateway has 30 seconds timeouts. This means even though you have even though we had 5 minutes to run our function, we were limited to 30 seconds because of API gateway, for example. And one thing about monitoring is I'm up, but I think we can continue a couple of more minutes. So fixing it slow was harder. There are a couple of reasons. So because there are too many moving pieces. No? Okay. Basically, we did a lot of around monitoring things. We brought metrics, logs, and traces all together. You can go and check it out of Tundra. And actually, I did the same, more detailed presentation in DevOps Days Amsterdam, so you can go and check it out from YouTube as well. So, thank you.